Good evening, and welcome to the Scientific Adventures of Beardman. Today we're going to begin a unit on waves. So we're going to begin by looking at what is a wave. Well, there are a couple types of waves, first of all. And there's a couple types of one of the types of waves. And there's 7 types of another type of wave. Anyways, lots of typing of waves. But first of all, we have the princess wave, which is short, short, long, long. Short, short, long, long. Okay, I'm just kidding. And of course, the Minnesota, I'm driving down the road, hey, wave. All right, for, saying hi to other cars. Anyways, the main type of wave we're going to look at the beginning of the unit is a mechanical wave. Okay? A mechanical wave is a disturbance in matter that carries energy from one place to another. Okay? This means that we have some sort of material, could be air, could be water, could be steel, could be anything, and that matter gets moved, gets disturbed from its rest position. The type of matter we use is called the medium. Okay, the medium is the material that the wave is traveling through, and so that material, that medium, will move as the wave passes through. There's 2 ways in which it can move. Actually, there's many ways in which it can move. Most of them involve moving along the surface between 2 media, or the boundary between 2 media. We call those surface waves, and there's many kinds of those, like Rayleigh waves and Love waves and so on, which you probably would study if you were getting in detail about seismic waves from earthquakes. But mostly we're going to talk about body waves, which are waves that can travel through the center of a material. The first type is called a transverse wave. And a transverse wave is a wave that causes a medium to vibrate at right angles to the direction in which the wave travels. So in other words, as the wave goes, the particles in that medium move perpendicular to the direction the wave is going. The wave is carrying the energy in this direction, and the particles, the bits of my finger, are moving up and down as the wave goes along. Okay? Reminds me of my hip-hop dance days. Good old hat tricks, So, anyways, the second kind of wave is a longitudinal wave. In a longitudinal wave, the particles move parallel to the direction that the wave is traveling. Okay, so the particles move back and forth as the wave goes this way. And fortunately for me, I can't compress my fingers or expand them longer, so I can't show you that with my hand. But with my fingertips, I could. So a wave would travel something like this. You know what? Let's go to the animations. First animation here is we see is the longitudinal wave I was just describing, where the slinky in this case is being compressed and then stretched out. That's a longitudinal wave. The particles are moving parallel to the direction that the wave is going. The wave is coming this way, and the particles are moving back and forth in that direction. The second kind we see here is the transverse wave that we already talked about, where we see the particles moving up and down, and that energy, while the particle is just going up and down, the energy is traveling into my ear, towards me. The final type of wave that we will look at mostly later on in the unit is an electromagnetic wave. And the definition of that is a transverse wave consisting of changing electric and magnetic fields. I'm not a huge fan of the term transverse because there are no particles moving perpendicular, but if an electromagnetic wave was traveling this way, the electric fields would be changing in this direction, the magnetic fields would be changing in this direction, and they would be perpendicular to the direction the energy is going. So we can use that word transverse in order to describe that aspect of the electromagnetic wave. And that's types of waves. Tune in next time and we're going to learn a little bit about the different parts, like the crest, the trough, the amplitude, the wavelength, the speed, and we'll look at how those relate. All right, we'll see you next time on the scientific adventure of Beardman. During the week, practice your waves. See ya.